let's continue with chapter 3 and our conversation of life expectancy of a battery. So there are different types of sources, right? There are sources that have a limited life, like the batteries we use for our cars, like the batteries we use for our phones, like batteries that we can put on light flashes. So whenever you buy a battery for your car, like the example right here, it has to come with a rating. Like in this case, the rating says that it's 10 ampere hour. So there are certain, that is the special case, that's like the ideal case. But expected battery life depends on very different issues. It can be like if it is operating at maximum capacity, if it is going on and off, it is constant load, it varies the load. So it has different scenarios where we cannot say this battery is going to last you for this long unless we specify what is going to be the usage for. So whenever you're designing a circuit, you have to say, okay, this battery is going to last you for this time. Like for your phone, you can charge it for 20 minutes and it lasts you for 3 hours if you are constantly using YouTube. So then the microprocessor knows that the battery needs to be delivering a specific current for this amount of time. So that's how we can actually define the life expectancy of a battery. Otherwise, in generalities, we can only give estimations. In this example, it's saying that we have a 10 amp hour battery that is rated at that, and it says that how many hours is going to supply a constant current of 0.5. So if the current being drawn or being supplied by this battery, it is 0.5 or half an amp, the life expectancy would be just the rated divided by the current supply. In this case, half, so it will be 20 hours. So for 20 hours, we can have this battery supplying half an amp to whether that is a light bulb, a radio, or anything that we are going to have connected to this. So this is how I put it here in a formula, easier way for you to see it. So how many hours? Battery life in hours. So we have the rated value, which is ampere hour, and then we divide it by the delivery rate. How much current it has to be supplied. Like in the example, we have a 10 amp hour rated, and we have that is going to be supplying half an amp. So how many hours can it supply that? It can supply it for 20 hours. So that's how we do the life expectancy of the ampere hour rating of batteries or power sources in this case. Before we go into troubleshooting, I want to talk about efficiency. Efficiency right here, it's usually when we talk about efficiency, we refer to power efficient. So but right here is limited to power. It doesn't have to be limited to power. It's always output divided by the input, and we represent it by a percentage, so we do a multiplication. Usually if you take in chemistry or physics, we have a percentage error where you have the output over the input is the same idea. Efficiency is just the numerical or the mathematical calculation of how much of the input we are getting at the output. And in reality, nowadays, with electronics being so accessible and being so efficient, whenever you are designing something, it has to be above 95% efficient. If it's not, your design is not good. So 95% of the 95% efficiency, it is a acceptable efficiency, nothing less than that. So efficiency is always defined as out over in. In this case, I'm using power out over power in. It can be voltage out over voltage in, current out over current in. We want to measure how much are we losing, because ideally this should be 100%, but in reality we always lose something because we have heat, we have noise, we have different elements that are taking our efficiency away. So 95 and above percent are what it is considered good values for efficiency. So let's move on. Troubleshooting. Here is for the lab. This is when you have designed something, when you are working on your design and your circuits stop working. So how do we start tackling? A lot of us start just like, okay, I'm gonna pull it apart and build it again. But how about if that is not an option? If you're just working a section of it and it's very complex, very expensive to do that. So you have to know how to start doing the troubleshooting. So the best way is like, did it ever work? You gotta ask your question. Ask that question, was it working before or was it always broken? If it was always broken, then your whole design is not properly. But if it was working and then suddenly it stopped working, then you gotta think, okay, what did I change? How long did I have it on? Was there any smoke? Was there anything pop? Did anything look different than what it looked before? So that's how you have to start looking at it. What is it doing now that it is different? How do you know that it's not working? When did you find out that it wasn't working? Is it any of the components overheated? Is any of the components discolorated? Those are the things that you have to ask before you start into the troubleshooting. Once you have answered those questions, we can move and say, okay, I'm going to check the schematics. You have to be giving a design process, and in that part of it, you're going to have the blueprints. Like when you build a house, you have the blueprints to follow. You're going to have the schematics. A schematic is just a symbolic representation of your design. Then you're going to read the manuals and say, okay, if any of the symptoms of my design is in the manual, could this have happened because of that? And if that's the case, then you might be lucky. You might have a solution there. Somebody have pre-documented the same issue and there is a solution for you. So it is important that you don't start right ahead trying to fix the solution, but look for resources. Because when you work at big companies, problems happen all the time, and every time a problem happens, it gets documented how it happened, what were the characteristics, and how they properly fix it. So that information should be available for you to read, to look out, and know how to fix it. And then review. How did it happen? When happened? What did you do different that now it happened? There are many different ways, if you were not lucky enough and find documentation to see that the problem had happened before and how they fix it. You can check a point in the schematic design, in the schematic process, and start troubleshooting. The half splitting, it refers to when you start from the middle of the drawing or middle of the schematic to the end. From the middle to the end. So you start checking that to make sure that that part is okay. If you check the half of the design, half of the circuit, it has no issues, then you can move from the middle to the beginning to see what happens until you localize what is happening, and then you can modify properly. And very important, you have to document how you fix it. Important keys, important definitions. We define what was Ohm's law and how it is proportional, or how its relation with voltage and current. Linear, we characterize that the relationship between voltage and current is linear, and that's how you can find the resistance. Energy, we define as the ability to do work. and it is in units of joule. We define that power is closely related to energy in the way that power, it is the rate at which the energy is used. And we also find that the units for energy or work are joules, watts. We define that was the unit for power. The kilowatt hour, we found out that was a common unit used for mainly utility companies. Ampere hour, we use it to calculate the life expectancy of a battery. Efficiency, we talk about the efficiency, how the output over the input times 100 gives you a percentage efficient, to see how much are we losing, how much power are we losing into the system. That's it. That concludes chapter